Hello everyone. Today let's solve the problem number 198, house robber. What the question states here? One second. So we are given an professional. You are a professional robber planning to rob houses along a street. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money that is stashed. So we have to keep in mind each uh, house has certain amount of money that is stashed. In this case, the house 1 is stashed with money 1, house 2 is stashed with money 2, house 3 is stashed with money 3, and house 4 is stashed with money 4, right? So each house has certain amount of money stashed. However, you cannot rob two adjacent houses because their security systems are connected, and doing so will alert the police. And here when they say adjacent houses means we cannot rob the next house. So if we are robbing this house, we cannot rob next house where the element 2 is present. So we have to rob the alternate house, right? So suppose if we are planning to rob house 1 here, next we have to plan to rob house number this one 3 or at the index 2, as this is 0 index, right? So next we cannot rob the next house. Here we will stop. So 1 and 3 in this case if we start from index 0, right? So I hope this is clear. So we cannot rob two adjacent houses because their security systems are connected, and doing so will alert the police. So that's what they have given here. Given an integer array nums here, this one you clearly see nums where iterated value of the nums represents the money in ith house. So that's what I have said. In the first house they have stashed this one 1, in the second house they have stashed 2, in the third house they have stashed 3, and so on, right? We have to return the maximum amount that we can rob without alerting the police. When they are saying we have to return the maximum amount of money without alerting the police means we should not this one rob the adjacent houses. They have clearly said we should not rob the adjacent houses. Instead we have to rob alternating houses, right? So return the maximum amount we can rob, or you can rob without alerting the police. So that's what they have given here. So I hope the question is clear. In this case you can clearly see here 1 plus 3 is nothing but in this case 4, right? So let's come to example 2 here. We will rob this house first, then we will ignore the adjacent house and we will rob the this one third house, or the house this one the house present at the second index. 9 plus 2 is nothing but 11. Next we will ignore this one and we will rob the house at the this one index 1 2 3 4, index 4, right, which is having the money 1 stashed here. So 9 plus 2 plus this one 1 is nothing but 12 here. In this case output will be 12 in this case. I hope this is clear. Output will be 4 and output will be 12 here, right? So I hope the question is completely clear. Let's discuss the approach step by step, then followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach. So here let's discuss the approach step by step. First thing that we have to keep in mind here is we are going with the dynamic programming here. We are going with the approach dynamic programming. So just give me a second here. Yeah, we are going with the DP right here. So we will be making use of dynamic programming or the DP to solve this particular problem. So instead of recursively computing all the possible ways to rob the house, we'll be making use of the iterative bottom-up DP approach. Iterative bottom-up dynamic approach means bottom-up means from the end to beginning, means we will start from here. Instead of this one top to bottom, we are starting from bottom up, means end to start, right? End to start, we'll start from this one, right? So we'll be going with the bottom up dynamic programming. And one more thing, we are going with the iteration, means we are visiting every element here once, right? So we are going with the iteration, not the recursion here. So we are visiting the every element once here. Let's see that one further. Just keep this in mind. We are going with iterative bottom up means instead of starting from the this one index, this one we will be starting at the last index. So let's see this one further. Just keep in mind that we are going with iterative bottom up dynamic programming, right? So I have considered the same example, first example that they have given in the question. You can clearly see 1, 2, 3 month they have given, output has to be 4, right? So we saw how we got the output 4. So step 1, what we will do here, we will start from the last, we will be moving backward. That is when I said bottom up dynamic programming here. We will be starting from the end. This one, last one, we will be moving backwards. So that's what they have given here. Step 2 here is each house we have two choices. One is first one, we have house here, adjacent houses. We are starting with 1. We will skip the element 3 here because this is the adjacent house. If we rob this house, we will get caught to the police, right? So we will skip this house. Next, we will move to this one 2. Again, we will skip this one and we will move to this one. No element is found here, so 1 plus 2 in this case. So from behind we are doing, right? So we will be going with the rob money from next house. Nothing but skip the house part is rob money from next house. As we are dealing with the iteration, we will go with rob money from the next house as well, and skip the house as well, and rob the house as well. When I say rob the house, it is rob money from current house and table of I plus 2. I plus 2 is nothing but here in this case. So first we will start with this one, as I have said, 1, and we will ignore 3 and we will move to 2, and then we will ignore 1. This is it. 1 and 2 we will consider in this case. So just showing you for the example sake. So let's implement the step 2 here. We have considered step 2 here. Let's implement the step 2. So the nums array they have given here is n, or I'll just consider for the nums here, this one n I'll consider. So we will be going with array of n plus 2, and initially we will be filling that one with a 0. So this will be very helpful in this case. So we will be initially filling this one. We'll be considering array n plus 2 means extra 2 tables. We are going with the DP table. We have 3 tables. Here you can clearly see 1, 2, 3, 4. With the value, we are going with bottom up means we are starting from the last index. First 1, 3, 2 and 1. 1, 3, 2 and 1. You can clearly. And we are going with the array of n plus 2 means we have initially we will add 0 and 0. We will be having 6 elements initially, right? So array of n plus 2 is of n plus 2, and then we will fill that one with the 0 initially. You have to keep this in mind. So why I said this one means here you can clearly see the computation here as table of 3 is m is nothing but the max here. Max of 1, current money we have in house, 1 plus table of 5. So you can say table of 5 is not present at all. How are you taking table of 5? So we are considering the array of n plus 2 and we are initializing these two with 0 here. That is how we get table 3 and table 4. This one is table 3, table 1, table 0, table 1, 0th index, right? Table 2, table 3. This will be 0 will be table of 4 and this will be table of 5 here. So 0, 0. We are going with array of n plus 2. This one we have to keep in mind. Max of 1 of table of 5, nothing but 1 is current value. Table of 5 is 0 initially and table of 4 is also 0 initially. You can clearly see here in this case, right? Here you can see this one, right? So whatever I have written. So this will be max of 1 plus 0 is nothing but max of 1 and 0. It will be 0 itself in this case, right? Max of 1 comma 0 is 0. Sorry. Just give me a second here. Did I miss something here? So max we are going with, right? Not the minimum value. So just give me a second here. Max of 1 and 0 here, it will be 1. So sorry, not the 3 here. So table of 2, when we consider here, max of 3 is nothing but the current value here I am considering. Table of 4, this one adjacent house, and this one is alternative house. So this one is nothing but the adjacent house, this one is nothing but the alternating house in this case. So table of 4 we have the value 0 here we will consider, and table of 3 you can clearly see here, and this table of 3 is 1. This is table of 3, this is table of 2, this is table of 1 value, this is table of 0. This is 0 will be table of 3 and 0 will be table of 4. So I have written in red so that it will be easier to understand here. So this will be 3 plus 0 comma 1. 3 and 1 it will be. Maximum of 3 and be 3. We know this one, right? So let's come to the table 1. Max of 2 plus 2 is current value plus table of 3 adjacent house comma this one is alternative house. Table of 3 we have the value 1 here in this case, right? 2 plus 1 is nothing but 3. Table of 2 we have the value 3 here. So 3 comma 3, max of 3 comma 3 will be any 3 you can consider here, 3. This will be, and final one is for the table of 0. Table of 0 max of 1 plus table of 2. Table of 2 we have value of 3 here. 1 plus 3 is nothing but 4 here, and for the table of 1 we have the value 2 here. 1 and 2, 1 plus 3 comma this one 3 we will consider here. Table of 1, right, we are considering here. Yeah, we have to consider 1 plus 3 here in this case comma 3. In this case we'll go with 4 because 4 comma table of 1 here is this one, right? So we have to consider 2 in this case. So sorry, this one is not 3. This one is 4 comma 2 is nothing but a max of 4 comma 2 will be 4 itself here. This one which is present at the index 0, this one is house index 0, 1 2 3. So this one we have to return as output, nothing but 4. So the output we got is 4, and by making use of the bottom up iterative bottom up dynamic programming, and here the output they have given is also 4. So I hope the approach is completely clear. We are returning the 0th index, nothing but table of 0 we are returning here. So initially what we have to in mind, we are initializing the array with n plus 2, 2 more values, just for the sake of easy computation we are doing this one. So table of 1, we saw the computation here, we got 1 3 5 and 4. Table of 0, 0th index, we will be returning this one. Table of 0, the value is 4, so the output will be 4 in this case. I hope this is completely clear. Let's come here. Table of 0, the value we have is 4 here. The same output they have shown in the example. So this is how we got the answer using the bottom up dynamic programming approach. So I hope this is completely clear. Let's move on with the edge cases. Let's discuss edge case one by one here. So the first edge case here, we are dealing with nums equals 5, single house. For the condition single house, input nums equals only one house we have, so the output will be obviously 5 here. You can just see it and you can just take a guess right here. This will be 5. So next one is for the two houses, nums of 2 comma 3. We have two elements here, so adjacent. So this will be in this case 2 3 0 0 according to the DP table. So we will start from here. We will rob this house. We will ignore this house. Again, we will ignore this house. This is it. 0 plus 3 will be in this case 3. Output will be 3 in this case. Same thing for this one as well. 5 comma 0 comma 0, because we are going with array initialization use array of n plus 2, right? So here from the backwards, we'll iterate. We will ignore this one, and this will be 0 plus 5. This will be 5. So this is fine. So I hope this is clear. Output will be 3 in this case for the condition 2 houses. Let's go with the third, this one edge case here. All houses have the same value here, 3 we are having, right? So this will be 3 comma 3 comma 3 comma 3 here, 0 comma 0. We'll start with this one. 0 plus 3, we will ignore this one. So next we will ignore this one, and we will rob this house, and we will ignore this one. So it will be 0 plus 3 plus 3 here. Output will be 6 in this case. So I hope the computation is completely clear. So the fourth condition, let's come to the fourth condition. Fourth condition, nothing but large input with alternating values. So we have 4 values here. So this will be in this case 2 1 1 2 extra double zeros here. So first we'll start from here. We will ignore this one, and we will drop this one. So we will ignore this one, and we will drop this one. So we will ignore this one. This will be 0 plus 2 plus 1, nothing but 3 in this case. Output will be 3 in this case for this one. So did I miss something here? 0 plus 2 Just give me a second here. So yeah, I hope this is clear. All the four edge cases. I'll come here. What are all the edge cases that we considered here? Single house. The second one was for the two houses. The third one was for all houses have the same value, and the fourth one was for the large input with alternating values. So these four edge cases we need to keep in mind. So I hope the approach and edge cases are completely clear. Now let's start writing the. So let's start writing the code. So during the approach, as I've said, we'll be creating the DP table, and we will be initializing that one with the array of length of the nums plus 2 for the easy computation, right? So I'll just give here let table. So let's create the DP table here. New array of length of the nums plus 2 just for the e computation. We saw this one right in the approach. So I hope this doesn't create any confusion here. This is not ambiguous here. So I hope this line is completely clear. So why we are going with nums dot length of the nums plus 2 just for the sake of easy computation here. Next thing is base case. When no houses left, initially let's initialize the first house, nothing but nums of this one. In this case, for this example, it is table 4 and table 5. Here 0, table 0, table 1, table 2, table 3, table 4 and table 5 we are going with, and we are initializing that one with 0. So how can we do that? Here length of the nums, we have to articulate our thought process, whatever we discussed in the approach, right? So we just have to articulate same thing in the form of code here. Table of uh, nums of nothing but the length of the nums plus 0. Yeah, I'll initialize this one to 0. Let me copy the same thing. Let me do it for the next one as well. Table 4 and table 5, 2 we are considering here, right? Length of the nums plus 2. So here instead of 0, this will be length of the nums plus 1. This also we will be initializing this one to 0 here. I hope this is clear. Next step is we are iterating backwards, right? We are considering from here backwards, right? We are considering the last element, and we are robbing from backwards, right? So how can I articulate that in the form of code? Simple for loop here. We are going for the bottom up iterative bottom up DP approach, right? So let's this one start iterating from the last element backwards. So I'll just give here I equals length minus 1 here, I greater than or equal to 0, I minus this is fine. So I hope this is clear. The first step, the first case we saw here is we have to skip the current house. So we have to consider that one, because we are going with the iteration in this case. When it comes to code, we have to code that one, but we in the case one we have to skip the current house. We have to rob only the this one alternate house. We have to skip the adjacent house, and we have to rob the alternate house. So how can I articulate that one in the form of code? I'll just give here some if skipped, nothing but the adjacent house. For the adjacent house, this will be next house, right? This will be table of I plus 1. So some one more variable I'll consider sum if robbed for the alternative houses that we need to rob. So here it will be iterated value of the nums plus, so this will be table of I plus 2. This we have already considered in the this one what you call approach. So we have computed and we saw how we got the output as well. So this shouldn't be ambiguous at all, right? I hope this step is completely clear as well. So here finally we have to calculate the iterated value of the table here. This will be math.max of this one, sum if skipped and sum if dropped. Let's consider here this one and this one. Max we finally computed. If you remember, every step we got output for final at the final step at the table of 0, if you remember, right? So during the approach I showed every thing step by step. That's what we are doing here. We are just articulating that one in the form of code here. Table of I here as math.max of sum if skip, sum if drop. These two variables I'm considering, right? So adjacent and alternative houses that we are robbing. So finally what we have to do, we have to return table of 0 where the maximum money is stashed, or maximum money we can rob from the houses, right? So here I'll just return table of 0 in this case. So I hope these steps are completely clear. This is it for the code. Let me form this one once and let me hit the run button. I hope this works. Let's see. Yeah, you can clearly see here the sample test cases are getting passed here. Let me quickly hit the submit button. So you can clearly see here all the test cases are getting passed here. You can clearly see here, right? So the code works absolutely correct in this case. So here the code works absolutely correct. You can clearly see. So the approach. So now let's discuss the complexities of the code that we have written very quickly. So approach that we went with here is bottom-up dynamic programming, or iterative bottom-up DP we can say. So the time complexity would be here. Overall time complexity would be big of n. So we are making use of the for loop once here. You can clearly see here, right? So the overall time complexity would be big of n, and overall space complexity would be big of n as well. In the worst case, we have to store all the elements in the table, right? So this one you can clearly see array. In the array we have to store all the elements, so we are making use of the table here, DP table, and this one. So the overall space complexity would be big of n as well. So the time complexity would be big of n, and the space complexity would be big of n as well for the code that we have written. I hope the solution or the code that we have written here is completely clear, right? For now, this is it. Thanks for watching, guys.